Year 8 space knowledge test. I don't know why I always want to say space in a funny word and a funny way of saying it. Alright, if you do triple science, you do this in huge amounts more detail, right? But it's absolutely fascinating, all the stuff to do with space. Name the planets and put them in the correct order. My very easy method just speeds up naming planets. Mercury is the closest to the Sun, then Venus, then Earth, then Mars, then Jupiter, then Saturn, that's the one that makes everybody laugh for some reason, Uranus, Neptune, but then we're going to forget about Pluto because Pluto doesn't get involved in it anymore. Explain what causes day and night. Okay, so I'm going to do a circle here, right? And what I'm going to do is I am then going to draw me there. Okay, then just for the sake of this, I'm then going to draw another circle there. And this time what I'm going to do is I'm going to draw me there. That's a very big me. And over here, what I'm going to do is I'm going to do the sun. Alright, so what happens is the Earth, right, is obviously a certain distance away from the sun, right, and when sunlight is shining on, so directly at me there, I am then in day. Then what happens is Earth, a bit like my hand there, right, what it does is it rotates. And what it'll do is it'll rotate in that direction. So eventually what I will be is I'll then be at the back of the Earth. And when I'm at the back of the Earth, I can't see the sun at all. That is then night. Explain why a day is 24 hours. Okay, so I'm going to draw Earth again. Right, here's Earth. Right, here's me. Right, I'm right there. And again, what Earth is doing is Earth is again like my fist there, like that, right in the front of my face. Right, and what Earth does, it spins. Okay, it's rotating on its axis. Can't do it. No. Right, until the back of my fist then appears in the same place again. Right, and so what happens is I travel across the Earth like that, right, by the Earth spinning, and then what I do is I go all the way around the back, and then I come back round to this point here, and funny enough, that takes 24 hours, which is a day. Okay, so explain why a year is 365 and a quarter. So what I'm going to do is I'm going to draw the sun, right, colour it in because I like colouring in. Then what I'm going to do is I'm going to draw Earth there. Now Earth is a tiny little dot compared to the sun. And what Earth is doing, Earth is rotating, right? It's orbiting the sun. So what it does, it goes around there like that, and then it goes all the way around like that. Right, funny enough, that takes 365.25 days for that to actually happen. However, we always think that a day is 365. A year rather is 365. The following year is also 365. The following year is 365. Then we have one of those amazing leap years that is then 366. Okay, and the idea of that 366, that extra day, is to compensate for that quarter. So every 4 years we have a leap year which allows for that 365.25. What causes the seasons? Alright, so seasons, right, it's not completely, there's the sun, there's Earth. Now obviously Earth isn't quite as big. Right, now what Earth does is Earth orbits, right, the sun, and it's often, the seasons is due to the distance from the sun, but also what the actual Earth does. If I draw a diagram there like that, the Earth tilts towards it. So when the Earth is tilting towards it, it's hotter, and when the Earth is tilting away from it, maybe there, it's colder. Right, so the cause of the seasons is the distance from the sun, I'll write that down there, is the distance from the sun and the tilt of the Earth. What is a satellite? Give an example of a natural satellite and a non. Okay, So a satellite is an object that orbits another object. Okay, so then what we need is we need a natural satellite and artificial. Okay, natural satellite is the moon, because what the moon is doing, it's orbiting us. It's a natural satellite. An artificial one is, I mean, we actually call them satellites. So it's an object we have put in space. Okay, so it could be like a telescope that we put up there. Okay, interesting as well. I always thought that satellites were huge, but sometimes these days satellites can be the size of a shoebox. They can be quite small. Right, complete the diagrams of the moon. All right, so what I'm going to do is I'm just going to go down each individual one, and it's kind of like a bit like a shading exercise. Right, so a new moon is when there's pretty much nothing. So I'm just going to colour it all in. Now obviously my colouring in isn't the best. Crescent waxing, right, is when there is a tiny, oh my word, this is going to be hard to do, there's a tiny little slither on one side there like that. Okay, so all you can do is you can see a tiny little slither of the moon. Half moon waxing is when you can see half the moon. A gibbous waxing is when all you can do is you can't see a tiny little slither on one side. So see how the moon's getting bigger and bigger, so the waxing is then getting bigger. Full moon, a big white circle. Gibbous waning is when it goes in the opposite direction, where this time what you do is you lose a chunk off that side there. Half moon, waning, is when you've lost half of that one. Crescent moon, waning, is where it's nearly all gone, and then what you do then is you get a new moon. Okay, kind of makes sense. A lump of rock orbiting the sun left over from when our solar system formed. Asteroid. Okay, there are all of those films where big rocks flying around in space. The imaginary line that the Earth spins around is the axis. Okay, so where you've got that there, what you've got is you've got a line that goes through, and that's what the Earth spins around. Dust particles frozen in ice that orbit the sun. There's a comet, right? Halley's Comet comes past every something like 76 years. Galaxy, a number of stars and the solar system around them grouped together, right? So it's our star plus many, many billions of other stars that make up our galaxy. A lunar eclipse, when the Earth comes between the sun and the moon. So what we've got is we've got the sun there, right? We've got the Earth there, and we've got the moon there, all right? So that means that the moon disappears, all right, because the Earth has then got in the way of it. A meteor is a piece of rock or dust that makes a streak of light in the sky. A meteorite is a stony or metallic object that has fallen to Earth from outer space. Sounds cool. All right. A solar eclipse is an eclipse where the moon comes in front. So this time I've got the sun there, Earth's there, and then the moon gets in the way. So a solar eclipse is when the sun disappears. A lunar eclipse is when the moon disappears. Right. Again, lots of terminology, right? And what you've got to do is, if you don't understand some of the things that I've then talked about, right, just go on Google, go on YouTube, and just search them up. What they'll do is they'll do much better diagrams than I've done on this, right, to try and explain how long a day is and seasons and things like that. But just keep researching, right? Researching and get to understand, because it is actually incredibly useful. Go back. Go over it again, make sure you've written it all down, then go to the blank video, and when you've seen the blank video, test yourself by writing down your answers.